Hello, welcome to my talk, Java, the non-enterprise parts, also known as Java Gotchas, also known as You Don't Know Java. I'm Mike Hand. I'll get the obligatory intro out of the way. About 6 months ago, I joined a startup in Columbus called Rove. That's what I've been doing lately. Our goal is to turn every renter into an owner. And right now we're working to make it possible for renters to own a stake in the apartment building that they live in through a product that we call rentership. I won't dwell on that, but I do think it's really cool. And if it piques your interest, you can check that out at rove.com. So that's what I'm working on now. As far as background, I've worked in a number of environments, including defense contracting, small privately owned businesses, consulting, of course now startups, all kinds of stuff. I primarily have experience in Java, especially as the years go on, but with some other odds and ends like C++ and JavaScript as well. But stronger than an attachment to any specific language, I have a strong interest, just kind of in general, on what makes languages tick. That's software languages, human languages, languages of all kinds, really. I used to say that I've accidentally read decent chunks of the Java Language Specification, but as time goes on, I just have to start saying I've actually read decent chunks of both the Java Language Specification and the ECMAScript language specification, which is what JavaScript adheres to. And there's just so much more depth than like, is this language statically or dynamically typed? Is it strongly or weakly typed? So we'll dig into kind of some of those cobwebbed corners this hour. One thing that I want to say before we begin, there will be a lot of code in this talk. I will be showing and running code examples for basically everything from here on out. This will be the end of the slide deck. So I highly, highly recommend before we begin that you maximize your browser window and also like collapse the chat window and hop in, whatever makes the screen bigger. I'm going to flip over to my slide deck and probably should have made that bigger earlier. I'm going to turn off my camera now to encourage you to focus on the slide deck. And we'll go ahead and get started. One last final thing, I guess, before we get into it. I've personalized, I think, all of these code examples, but yes, many of them were sourced from various places over the years. I unfortunately cannot provide citations for probably almost all of them. Some of them are random code snippets from, maybe a forum post or a coworker, and you can find variations on all of them online. These are just my humble take on these couple concepts without claiming to have been the primary source on any of them. All right, so let's get started. And let's start with something nice and familiar to get off the ground. Everybody has probably been asked this in an interview, right? String equality. How do we compare strings? And I'll do my best to keep the code kind of large and visible as much as is practicable. If there's a major issue with that, or if I somehow forget on either side, over here on the code side or over here on the output side, put a message in the chat for me, and I'll try to expand that. But okay, so string equality. We've got a pretty simple main method here. But let's kind of step through this and see what happens, because there's a couple things to talk about. So I've got a breakpoint here. So we've already run these first two statements, assigning to S1 and S2 these string literals, HELLO. And now we're going to compare and see if they're equal. So let's step past this line. Now, unfortunately, I can't make this bigger. I haven't found a way to do that. When we look at output, I can try to make that bigger. So there's kind of two ways to view this. The variables will appear over here, but IntelliJ is also going to kind of inline all of that as well. So we can see here that test1 was true. Those are equal. Okay, let's step past a couple more of these. Now we have assigned to S3 and S4 additional strings, also HELLO. And now let's see if those are equal. And they're not. Okay, interesting. Now let's assign two strings in yet another way. Instead of a string literal, we're going to pass into the string constructor two strings that already exist. Now, are those equal? Those are not double equal either. Now let's combine the two syllables hell and low to equal the string HELLO, and then we're going to compare that back to our first string. That one is double equals. And one last one, let's use the string constructor, but then we're going to call this intern method on the string object that gets that's the result of that constructor call. So that's going to be assigned to string 8. Now we're going to compare our first string hello to that last string, and are those equal? And now all of a sudden those are equal again. So why? Why are all these different steps the way that they are? Why are some of these double equals and some of them aren't? And of course, yes, by the way, all of these would be dot equals true. Now, we're going to get kind of a big hint by looking at the Java doc for the intern method. So let's kind of parse through this. That dot intern method on the string object, that's going to return what they call a canonical representation for the string object. Now they're going to go into a little bit more detail here. A pool of strings, initially empty, is maintained privately by the class string. This is commonly referred to as the string pool. When the intern method is invoked, if the pool already contains a string equal to this string object, as determined by the equals method, so the equals method does come into play here, then the string from the pool is returned. Otherwise, this string object is added to the pool and a reference to this string object is returned. So that's how the string pool is built up. Okay, so I'm just reading this. Hi, Mike. Might need bigger text, better contrast. Okay, I'll try to make this a little bit bigger, and I'll try to continue with that as we go along. Please make sure that your browser windows are maximized, as much as you can. I'm trying to do the best to react to this environment, but we weren't necessarily aware of all the parameters beforehand. So I do apologize about some of that. So that's how the string pool is built up. If there's already a string that exists in the string pool and you want to define a string literal that matches it, the JVM is going to say, hey, I don't need to store that in memory again, already have it. So here it is. If it doesn't already exist, it'll say, I'm going to make it once, I'm going to put it in there, and if we need it again, then I already have it, we're good to go. So it says it follows that for any two strings s and t, s.intern double equals t.intern, that'll be true if and only if s.equals t is true. And finally, all literal strings and stringed valued constant expressions are interned. So that's the quote, HELL quote. All literal strings are interned automatically. String literals are defined in section 3.10.5 of the Java Language Specification. So yes, the Java Language Specification comes into play. So that kind of explains why these are going to be equal, because string literals, they get interned. That explains why this one is equal, because we specifically asked for it to be interned. And for all these other ones where we used the new string constructor, we explicitly asked for a new string, for a new string object. So we basically told the JVM, forget about the string pool, I want something new. There may be reasons that you want to do that, but just be aware, if that's happening, that's why dot equals is really the only safe way to compare strings. All right, so let's move on to example B, integer equality. Kind of along the same vein. I'll try to make this as big as I can here. We've got another simple main method, This time we're going to create and assign two primitive ints. And let's just go ahead and run this with the value of 42. And now we'll test, does A equal B? I don't think we'll be that surprised to find out, yes, of course, A equals B. With primitives, that's pretty straightforward. Now we're going to use the integer class, and we're going to assign them the same primitive value, 42, to both of them. Let's do C, and we'll do D. Now we're going to compare C and D. Yes, those are also equivalent, double equal equivalent. All right, now let's compare the primitive to the object, and let's see what happens there. Yes, those are also both double equal equivalent. Okay, now let's try to get a little bit more out of the box. How about 42, 42? We sorry, just reading a message in the chat there. We already did it with 42, but how about 42, 42, 4,242? That should also be equal, right? We assign the values. All of a sudden now, double equals is false. Okay, well, but we know that dot equals is going to be true. So why does this work when that doesn't? And why does this not work? This is just 42, but watch what's going to happen. When we call the integer constructor, all of a sudden those are no longer going to be double equal true. But if we call integer dot value of, all of a sudden they're double equal true again. Now this is for a similar reason. And in this case, if we go and look at the Java doc for value of, we're going to find that value of returns an integer instance representing the specified primitive int value. If a new integer instance is not required, this method should generally be used in preference to the constructor, as this method is likely to yield significantly better space and time performance because it caches frequently requested values. So when it says that it will always cache values in the range of -128 to 127 inclusive, and may cache other values outside of this range. And we can see that that's exactly what it's doing here. So in the value of method, we're going to get the primitive int I, and we're basically going to say that value of I, is it greater than or equal to our lowest value, which is -128, or is it less than or equal to our highest value? And we'll look at that one in a moment. If it is, then the JVM has already created those integer objects, and it's just going to return it. It doesn't have to instantiate it new. It says, I've already got one. I'm going to return it. Now let's go look at what happens with high. You see, low was defined as, if I can hover correctly here, as -128. But high, okay, it does say 127. Sometimes it doesn't. High, oh, that must be because I'm still in the middle of executing. High is actually not set here, you see. It's going to be at least 127, but it could be configured to be higher. So we could actually go and we could set some kind of property here to make that equal to or greater than 4,242, and then that should still work, because they're going to be pointing to the same object in memory that was already constructed. But otherwise, if you're outside of that cache range, then a new integer object is going to be constructed, and that's why they will not be double equals, but they will be dot equals. So value of is going to be called when you do it explicitly, or when the primitive is passed in. But if the primitive that's passed in is outside of the cache range, it's still going to have to use the constructor. And you'll notice that IntelliJ is actually giving me a hint here. Let me just play through this. IntelliJ is actually giving me a hint here. It's going to say two things. Let's look at the second one first. The integer constructor that takes the primitive int is actually deprecated. And it's also saying unnecessary boxing, new integer 42. And if I click this to remove boxing, IntelliJ is going to say, what you really want to do is just assign the integer object G that primitive 42. So IntelliJ trying to help me out there. All right, let's look at another example, executable comments. And this is one that I believe I promised in the abstract. So I've got a simple class here with a simple main method, and that main method has only comments inside of it. You can see every line starts with a // but let's run it and see what happens. And okay, the output's down here, but it says this is a comment, so it will never execute, and it also says the value of C is 5. And we can see up here, yeah, I have system out print line that's supposed to print. This is a comment, so it will never execute. And I've also declared A and B. I've added them together, and then I've printed out the value of C. How did these lines execute? Because they're completely commented out. Well, the eagle-eyed among you will notice that every line that I've quote unquote executed that was quote unquote a comment starts with this /u000d. Java is processing that as the Unicode new line character. Unicode is valid in Java, so /u, and then 000d is for new line. So in each of these lines of comment, they're actually, for instance, this line is showing up as a comment that's empty, and then int a equals 2. So you'll notice that IntelliJ is only so good at parsing this. I do have some highlighting up here that says remove this unused a local variable. Really what it should be complaining about is that I've redefined a. And I'm actually not sure what will happen, but if I try to run this, yeah, I do have the JVM is saying, hey, you've already defined a. IntelliJ is not quite smart enough to figure that out, that it's probably just completely ignoring that commented line, maybe for efficiency or something like that. But that's really how that line is being parsed. So the interesting thing is you can write a program entirely in Unicode characters, and so I've gone ahead and done that. And that one's called ugly.java, and here it is. And this one, for reasons that will become obvious very quickly, was completely copied and pasted from somewhere online over the years. Now, you'll notice that I had been, and I don't think I can make this bigger either, sorry, but I had been labeling these as, example A, B, C, and I ideally would have named this example D, ugly.java. But when I rename this file, to D, ugly.java, and you'll notice also IntelliJ doesn't give me, the run option here. It's not able to parse that out. So I have to come up here to the menu, and can I get it to do? Why won't it do? Give me D ugly.java. Well, okay, this is maybe why, and this is what I wanted to show. There is a class defined here called ugly, and so it needs to be in a file called ugly. And I've put in comments over here what this code looks like. You see it's nicely formatted as a box, but there's actually a fair amount of spaces in here to kind of make it look nice. And that's all these 0020s. These are all space characters. And so this won't actually run if I named it dugly. So what I had to do was name it just ugly and kind of work around that to keep my examples in order. And what we will find when this runs, hopefully after messing with this, I can now get this to run. Will this work? Oh, okay. Sometimes I have to come up here and try to do this manually. It really doesn't like to make this happen. Okay, here we go. You see that I get hello world. That's the output of this block of Unicode characters. And we can see here, what do we have? Public class ugly with a public static void main passing in an array of strings called args. And what does it do? System out println hello world. And all of that is properly formatted. Now, the interesting thing here is even though IntelliJ is complaining about all these illegal characters, it's also highlighting this class name and saying, hey, you should have a private constructor for this class. You should also rename this class to match, the Java naming standard. Start with a capital letter, and then have, a mix of lowercase and capital letters. It actually is named that way, just with Unicode control characters. And then about the class, the method main, it's going to tell me the same thing. It should start with a lowercase letter and then have camel case. And about the variable args, it's saying that it's unused, which is true. It has to be there for main to work, but it's unused. And so it's smart enough to pick out the class name, the method name, and the variable name, but IntelliJ isn't quite smart enough to completely parse this and understand what it's doing. Thankfully, it does still run. So I can also put a breakpoint here, and I can try to debug this, but it's not actually going to stop at that breakpoint. Overall, this is a bad way to write your code, but I definitely thought this was one of the more interesting examples that I came across about how to abuse Java. Okay, pressing on. Now all the way to example V. How time has flown. Did you know that you can just take a URL, drop it straight into your code, and that's a completely valid line of Java? That's because essentially Java has gotos. They're not actually gotos, they're actually called labels. But essentially what's happening is the HTTP is a token, then a colon. That's how you put a label in Java. And then the rest of it with the // that becomes a comment. And so I can have HTTP and HTTPS, and these are labels. Aside from that, this is a very simple, a very usual Java program, a main method. We have two for loops, and the first one has a label of HTTP, the second one has a label of HTTPS, and I can use those labels to break out of the corresponding loop whenever I so choose. So theoretically, this would go from 0 to 5, but when I equals 2, I'm going to break out of the loop that's associated with this label. And same thing on the inside from 0 to 5, but when that loop equals 2, I'm going to break out of the loop that's associated with that label. So if we run this, we will see the output here. We never get higher than 2 for the output. Now, of course, you can only put one HTTP and one HTTPS in your code, otherwise it'll complain that you've defined that label twice. That would not be valid, but you can have each of those in your code at least once. So if you accidentally paste a URL straight into your code, it's going to be completely legal. Now, the interesting thing is IntelliJ is going to tell me to refactor the code to remove this label, and the need for it, because this is definitely not considered a best practice. I have used this labels once or twice. They can be really useful and sometimes a much more graceful solution than hacking around not using labels, but it should definitely be used very judiciously because it's not something that people are going to be expecting. Okay, let's talk about final. So let's take a look at this. This is a very simple class. It has 6 static final ints, but let's focus on A, B, C, D, and E. These are final. So once once we declare them, their value should never change, right? That's what final means. It's final. It can't be modified. So let's look at what we're doing here. A is going to be assigned from this method printVars. PrintVars is going to print the value of A, B, C, D, and E, and then it's going to return 5. So A should have a value of 5. B, we're just giving a value of 10. C, we're going to assign its value from the result of a call to math.min. And we know that math.min on 10 and 20, that should also return 10. D is going to get its value from a call to this get value, which is going to return the constant 10, which has a value of 10. And then E is also going to get its value from printVars, which again will print A, B, C, D, E, and then return 5. Once we define all those, we're going to come into main, and we're going to run printVars one more time. And since all of these are final, those 1, 2, 3 calls to printVars should all print the same thing, right? So let's go ahead and run it. And they don't. We get 0, 10, 0, 0, 0, then we get 5, 10, 10, 10, 0, and then we get 5, 10, 10, 10, 5. But these are final. What gives? Why is this happening? Well, final really just means that the value can't change after it's been assigned. And the value doesn't get assigned until it's assigned. Up until that point, the value of a final variable is either going to be false or Boolean, 0, any of its various 0 forms for any sort of numerical, 0, 0.0, etc. Or for an object, it'll be null. And then once it's assigned by you, the developer, the programmer, then its value will stick. So let's step through this in debug and see how that works. Okay, now we will be over here, apparently. Okay, so let's watch this view, and we have here all of our static final ints. You'll notice that 10 is filled in because that one is known at compile time. It's a constant, 10. You'll notice that B is filled in because similarly, it's also a constant. That's a numeric literal. It's known at compile time, so that value is automatically assigned. Now, technically, the rest of these are also known at compile time. PrintVars only ever returns 5, and it's also a static method. You'd think that maybe it would be able to sort that out. Yes, that method is doing other work, but that other work doesn't affect the return value, but it's not used. You would also think that perhaps similarly, math.min, that this might be able to be known at compile time. Let's take a quick look at that method. It's very simple. It takes an A, it takes an B, and it doesn't need any other outside input. There's no other side effects. It just returns whichever one is less, A or B. So it's definitely something that could be known at compile time, but the JVM also decided not to fill that one in. So as we step through this, we're going to see A is now received its value here, 5, from printVars. B got skipped over because at that point, there's actually not a line of code to run there. B had already been assigned. Now we're here at C. The value of math.min is going to be assigned, and we're going to get back a 10. D is going to get its value from a call to get value there. So now D is 10. And then we're going to call printVars one more time, which should also return 5. And now E has been assigned. Now E has a value of 5. Okay, this time I'm going to run this and focus more on the output. Let me play through that and run this again. And let me trash this so we can start over. Okay, so printVars is going to be run. Oh, where am I looking here? Okay, I'm over here now. I don't understand exactly why all this is happening. Sorry for the confusion there. So we have The only one that's been assigned before print vars has run is B with the value of 10. We know that A now has its value, but that's not until after the output. Now we're going to assign C, and now we're going to assign D through getValue. So D will now have its value, and we're going to call print vars again. So that's going to output A, B, C, D, E, and we're going to see A, B, C, D with their values, and E still doesn't have a value. So the JVM says it's 0 until you tell me otherwise. There it is. And now, after all of those have been initialized, here we are, we're finally able to run main, and we're going to run print vars one more time, and now they all have values, and so we're going to get our final output, no pun intended, of 5, 10, 10, 5. So keep in mind, final isn't always final. It depends when you assign a value to final. It depends if you're using it before that value has been assigned or not. You may get some output that you don't expect. I have one more example for final that gets even a little bit more involved. And let's talk about what's going on here. So this is similar. I've got my static final int A, B, C, D, E. But in this case, instead of getValue returning a constant value, a numeric literal, getValue is going to return the value of C. And C is my static final int, whose value is getting assigned from print vars. Print vars here is the same print vars we've come to know and love. It'll output A, B, C, D, E, and then it's going to return the value of 5. So what happens here? This time, let's just go straight to debugging because we're getting a little bit more familiar with this. And let's this time check the values. So A is going to get its value from print vars. A is now 5. B is going to get its value from getValue. And getValue is going to return the value of C. C has not been set yet. C still has a value of 0. So B is going to get a value of 0. Now we're going to go through and set the value of C through a call to print vars. So it's going to get a value of 5. Then D is going to get its value from getValue, which is C. So it's also getting the value of C, but the value of C, even though it's final, has changed. So instead of B getting 0, D is going to get 5. And then E is going to get its value from a call to print vars, and E will get 5 as well. So you might think that they would all come out with the same value, but B kind of gets the value of C from before it's set, and so therefore B doesn't get to be 5 like the others. And if we run this one more time, but instead watching the output, at this point I think we'll get something that we've now come to expect, which is the first time we're going to print out all zeros. The second time, A and B have values, but B's value is still 0. And then the third time, A, B, C, D now all have values. Oh, accidentally hit it twice. And then after it was called from main, they all have their value. Now note that I cannot now go back and fix the value of B because it's final. It's still 0, but 0 doesn't mean that you can set it with something else. It's not the 0, the unset 0, it's the set 0. I told it to be 0, and so now I can't change it. So just because you have a value of 0 doesn't actually mean that it's in that quasi-final state. It is still final. You can't change it now because you forced it to 0. So the timing of assigning these is pretty nuanced. This is not an issue for most of the ways that this is done. Most of the time that you have, especially a static final int, it's because you're assigning some particular meaningful value, like pi, or some sort of constant. But if you're using some method where you know that you need something final, but you don't actually know its value yet, when you create the instance, keep in mind, you get to assign it once, but you only get to assign it once. And if you call it before it's been assigned, you're actually going to get a different value than if you call it after it's been assigned. So be careful with final. Okay, passing semantics. This is actually one of my favorites because this actually really gets into kind of back to what I was saying. What makes a language tick? This works differently in different languages. The way that passing semantics work in Java are different than the way passing semantics work, for instance, in C++. People say that the two languages are very similar. They have extremely similar syntax, but passing semantics is one way in which they differ. So let's kind of walk through this mentally and talk about what we think might happen. We've got a string builder, and we're going to create a new string builder with the constructor, and we're going to assign it the value lowercase string to get it started. And we're going to call this method that I called append maybe. We're going to pass in that string builder instance, and then what we're going to do with the string builder that we pass in is we're going to append a space and then another string, text of string. All right, so you know what? Never mind. Set that string builder to null. Okay, now we're back out, and we're going to output the value of that string builder. String builder obviously has a very nice toString method, and so what do we expect? Maybe a null, maybe null. Probably not a null pointer exception because we're not referencing it, but maybe the value of null, or it could be string space string. Let's talk about string builder 2. This one, to keep it kind of separate, it's capital string. Now, I'm going to call this method I called completely reassign. That method takes a string builder instance and says, you know what, I don't care what your value is. My job is to turn you into a new string builder with the value of my new string. Once this comes back from that, once execution comes back from that method, then we're going to call print line on string builder 2. Now, what will that one print? Will it be string? Will it be my new string? Will it be something else? Well, let's find out. So let's go through this with debug so that we can kind of watch how this works step by step. So let's instantiate SB1. It has a value of string. Obviously, that's what we expected at this point. Now you'll see that I have, I'm going to put this here for later, I have a breakpoint in my append maybe method. So let's step into that. And now append maybe has this string builder with a value of string. We're going to append. So now string builder has a value of string, and we're about to set it to null. And we see here, string builder, that's null. Over here, we see string builder is null. Now, after we step out of this method, here we are. And all of a sudden, now IntelliJ is telling us that SB1 has a value of string, but we just set it to null. And we're going to get out on the console string. When we print that, we're going to get string. Okay, well, let's check out the next one. We're going to create SB2 with the value of capital string. Here it is, capital string. We see that. Now let's call completely reassign, and we're going to pass in string builder 2. Here we are. It has a value of string, and we're about to reassign it to a new string builder with my new string. Let's step over that. And there we are. SB now has a value of my new string. We see that over here as well. You know, my new string. And as we step out of that method, all of a sudden SB2 has a value of capital string again. And when we output that, there it is, capital string. So why is this happening? Well, it's how passing semantics work in Java. In Java, and this is the age-old question, is Java pass by value or pass by reference? In other languages, like C++, you have to explicitly make that choice. Do you pass in the actual object? Do you pass in a reference to that object, a pointer to that object? In Java, you don't have a choice. In Java, pointers and references are completely behind the scenes. They're not exposed to the developer. The developer has extremely little control over how that works. And what happens in Java is, yes, Java is passed by value. but the asterisk there is the value that's being passed is the value of the reference. So what happens is our string builder is being passed in here, but when it comes into this one, it's because it's pointing at the same place. We're appending string, and then we're saying, you know what? This local one, this SB here, this string builder SB, I want to tell that to now point to a different place in memory. No. The one that was passed in is still sitting out here. It's been modified, and it's still pointing to the same place, to the same string builder object in memory that's been modified, and that pointer hasn't been changed. Same thing down here. When this one gets passed in to completely reassign, this string builder reference has the same value as the one that was passed in, but they're different. The scope of this one is just limited to that method. So now this one we didn't set to null, but we created a new instance, and now we're saying create that new instance. Now where is it in memory? Point me to that. And that's why this one was also similarly unscathed by its trip into the completely reassign method. Now, if you wanted those values to be affected by what happened in those methods, you would have to return that string builder object. You would have to return SB. And so you would have to have this return a string builder. Whoops. String builder. There we go. And when that happened, not only that, but you would have to reassign the value of SB1 out here to the return value from that method. Now, if we ran this, we would get different results. Okay, oh, all of a sudden now we're down here. And so we see now we did get back the value of null. We didn't change the second one, that's why that one didn't change here. And that's how passing semantics work in Java. So if you ever had an issue where you say you passed something in and you thought you affected it, but later it didn't seem like it was changed, it's likely due to the way that passing semantics work in Java, especially if you're coming from a language where passing semantics are different. So when you're porting code from one language to another, or when you're learning a new language, that's one of the things that you really need to be aware of, because it can have a big effect on how your code is written and how your code works. All right, know your types. This is a pretty simple one, but there's obviously a gotcha in here as well. Okay, so I've got this method main, and it has one line of code that we're going to focus on anyway. Don't worry about this right now. We'll come back to that later. What will this output? We've got CODEPALOUSA. I want this to output Code PaLOusa. What will happen when we execute this? I think this one will probably show up over here. Nope, down here. Did I get Code PaLOusa? Try to make this big. No, I got 1,168. Well, why is that happening? Well, there's an interesting reason why this is happening. These single quotes, right, mean that these are character types. This is not a string representing a single character. These are character types. And the char type, for instance, if we hover over this C, well, it's going to say remove. Oh, here's what I need to do. I need to go into debug. Yes, redo that. And then I need to step down to where C is defined. Okay, here we go. And now you'll see that C actually has a value of 99. It does say tick C tick, but it also says 99. Now, why is that? Well, this will be one of the few remaining slides that I have. You'll see here, this is the ASCII character chart. And I've highlighted C for you here. In ASCII, the character C has a value of 99. The char type, it will take an ASCII value, but it's actually a numerical type. So the value of C has 99, and all the rest of these characters have a numerical value associated with them from the ASCII table. So the JVM just says like, oh, math, simple. I know how to do math. I'll just add these up. And it happens that CodePalooza equals 1168. So you really have to know your types. I think the char type is not used very often. Usually there's just not enough room inside of the char type to represent a number. And we're well past the days, unless maybe you're working with embedded systems or something like that, where the increased memory of using ints or even longs really makes a difference. So chars and shorts, etc., they just really aren't widely used anymore. And that's one of the reasons that I think they're kind of not well understood, but it's actually a numerical type. You can happen to assign what seems like a single character string to it, but that's not actually what it is. All right, we do a quick check on time. So we've got maybe just a couple minutes left. Let's do this next one here. I call this one precision. This one I think is interesting because you know, we think of math as a science, as a constant, something where the rules are firm and in place and unchangeable. But we find out in Java that that's not actually true. So let's look at what we're going to do here. We're going to set a to the max value of integer. And that value is 214, 748, 3647, right? A pretty large number. It's the maximum number that we can represent in the space of an int. We're going to a plus equals 0, but 0 as a float value, 0.0. Then we're going to see if those are equal. Then we're going to minus 63, reassign it to A, and we're going to add 0 to it again. We're going to see if those are equal. Then we're going to minus 64 from A, assign it back, and then add 0 to A again, and see if that's still equal to integer max value. And then, because this is here, maybe you can surmise that at least one of those is not going to be equal, and we're going to kind of step through why. So let's debug through this. And do I have, yes, I got a breakpoint right at the top. So kind of drag this back over. A set to the max value of int. We're going to add 0. We see it kind of flash, A didn't change. And so is A still equal to the max value of int? Yeah, it is. Now we're going to subtract 63 from A. Now you can see, maybe we didn't remember it, but yes, it changed. Now we're going to add 0 to it. Oh, we see that it changed again. Now we're going to say, now that we've subtracted 63 and added 0 to A, does it still equal the max value of int? Yup, sure does. Now we're going to subtract 64 and add 0. And now does that still equal the max value of int? No longer true. Well, let's see if we can kind of examine why. Let's use B, assign it to integer max value, and we're going to minus equals 63 from B. Okay, there we go. Now here's what happens when you use the compound operator in Java. So the plus equals. What it's actually doing is it's going to take the value on the left plus the value on the right, and it's going to get the type of the wider value. So in this case, that's going to end up being a float. And then it's going to say, but you started as an int, and you have to end as an int. So I need to cast that float back to an int so that I can reassign it to B. And when that happens, we're going to lose precision. The precision loss comes because the float value and the double value, they can represent very, very large numbers, but they don't actually have very much precision. They lose some precision. And so when this gets assigned back, it's actually going to be the same value as where we started. We had subtracted 63, but when we add 0 as a float, we're going to end up back at integer max value. And then when we check if D or float d equals integer max value. Okay, yeah, here. So this is the float value of the integer max value, and you can see that it's not very precise. So there's a lot of wiggle room in there. This is all that we get because we need to multiply it by what is either 10 or 2 to the 9th. So there's a lot of wiggle room in there. It turns out we have at least 63 int values worth of wiggle room. So when we subtract only 63, have to go through the conversion to a float, and then back to an int, the loss of precision still puts us back at something that equals the max value of an integer. When we go to 64, that's enough of a threshold where now we're less than the max value of an integer, and that's why this was no longer true. So the lesson here is to be very careful about your different data types. Yes, they're all numbers, but when you're talking about a wider value with less precision, you can lose some of that nuance when you convert it back to a less wide type that has much more precision. This can represent every single number in its range. A float has to skip certain numbers so that it can represent very large numbers. Okay, let's see again on time. I think we're okay. We can do at least one more here. So modulo semantics. This one, admittedly, yes, it's at the end. It's not as strong, but just kind of want to point out that you have to be aware of corner cases, right? So it's very common, right? We want to determine if a number is even or odd. What's the standard thing that we do? Modulo 2, and do we have a remainder or not? If we don't have a remainder, it's even. If we do have a remainder, it's odd, right? So this should be either even or odd when we print it out. And what we're going to do here to get the number that we put in is we're going to take the string number and ask for its hash code. So let's just run this, and we should get either even or odd. And what we get is unset, the value that we set the string to originally. How did it not end up being even or odd? Well, let's debug through and see what's going on. Okay, so here we are. We've set our string s to unset. That value we expect to be updated, but it wasn't. So now let's see what n was set to. Okay, so it's this number -103,436,4087. And when that's the case, when we step through this switch statement, we go right over it. Neither of those cases hit. Why? Well, let's add a default case and say s equals like something simple like got here and break. Now let's run this again. And we see we hit that default statement. We are somehow neither even nor odd. Well, that's because this isn't actually a modulo operator, and it's because n was negative. So when we take a negative number and we do what we typically call the modulo operation on it, we're not going to get the output that we expect. So let's run this one more time, and let's see what the value of that modulo operation actually is, and it's -1. So while we've always assumed that the percent sign would just do division and leave us with the remainder, it actually respects the sign of the value that was passed into it. And so you're going to get -1 instead of 0 or 1. 1 here we would expect because it ends in a 7. It's an odd number. So beware the modulo operator as well. There's kind of a dark secret hidden in there. If you really wanted to do this, I guess you'd have to make sure that the number that you're passing in to the modulo operator always had positive magnitude Or you could add another case. You could have, well, let's play through this. And so you could have, case 1 and case -1 both lead to odd, something like there. That should work. Well, that might still have not worked. Oh, there we go. Odd. I don't know why sometimes I'm up here and sometimes I'm down here. To be honest, I haven't figured that out. So beware the modulo operator. I think at this point, I'm getting very close to the end of the hour. So we'll leave it there. The examples kind of get weaker in quality as we go along. So I think that's a good enough place to stop. I just want to say thank you for coming to the talk. I enjoyed putting it together. These are kinds of thoughts and ideas and concepts that interest me. If you have any like really great examples, I'd love to hear from you. You can find me on Twitter or email me at work. I am in the Code PaLOusa Slack. So feel free to say hi. Again, thanks for coming and thanks to the conference organizers as well. Hope you guys enjoy the rest of your conference. So have a good one.